Right, this is section R9. We're going to be solving multi-step linear equations. So to solve a multi-step equation, we have to simplify each side of the equation if necessary, and then use inverse operations to isolate the variable. So when we isolate the variable, we want to get the x alone, or the n, or whatever our variable may be. We want to get it all by itself. So looking at our examples, my goal is to get this x all by itself. So I have to undo everything on the left side of my equation to get that x alone. So the first thing I'm going to do is add 13 to the other side. So we want to do PEMDAS, or order of operations, in reverse. So I add 13 to the other side, so it cancels out on the left. So I have 2.5x is equal to, on the right side, I just add 2 plus 13, which would be 15. And then next, I have 2.5 times x. Since x is being multiplied by 2.5, to move it to the other side, I need to divide 2.5 on both sides. So x is equal to 15 divided by 2.5, which is 6. And that's our answer. So in the end, we're going to get x equals, or n equals, a number. So looking at B. So I want to solve for n. I need to get n all by itself. So again, I have to do PEMDAS backwards. So I start with what's being added or subtracted. So I have a plus 3 in my equation. So if I'm going to move it to the other side of my equation, I have to subtract 3 on both sides. So positive 3 and negative 3 will cancel. So I'm left with negative 2n is equal to, and on the right side, I just subtract these. 9 minus 3 would be 6. Next, since negative 2 is being multiplied to n, I do the opposite of multiplication, which is division. So I'm going to divide both sides by negative 2. So it'll cancel out on the left, and I have n is equal to 6 divided by negative 2, which is negative 3. So that is our answer. All right, let's look at C. So again, we want to do PEMDAS backwards. So I start with whatever I'm adding or subtracting. So since I have a minus 11 in my equation here, I'm going to do the opposite of subtracting. So I'm going to add 11 to both sides. What we do to one side of the equation, we have to do to the other. We have to keep our equation balanced. So I'm going to add 11 to both sides. It cancels out on the right side. I have negative 21 plus 11, which would be negative 10, is equal to 1/2 C. There's a couple different ways we can solve this equation next. C is being multiplied by 1/2. So in order to move it to the other side, I could divide both sides by 1/2. So it cancels out on the right. On the left side, I have negative 10 divided by 1/2. So when you have a fraction inside a fraction, we can keep, change, flip. So we keep the top, change to multiplication, and flip the bottom. So instead of 1/2, it now becomes 2/1, which is just 2. Because if we have a number over 1, it's just that whole number. So this would be negative 20 is equal to C. So I said there's a couple different ways we could have solved it. Another way, if I had negative 10 is equal to 1/2 C. Whenever I have a fraction, I can multiply everything in my equation by whatever the denominator of that fraction is to get the fraction to cancel. So I can multiply both sides of my equation by 2. So 1/2 times 2 would just be 1. So that cancels out on the right, and I'm just left with C. And then on the left, I have negative 10 times 2, which would be negative 20. So either way works. You can divide by your fraction or multiply by the denominator, and you'll end up with the same answer. All right, let's take a look at D. So we said we have to simplify one side of our equation first if we can. So simplify each side of the equation. So here, since I have two x's on one side, I want to combine those together. So I have 9x minus 6x. I'm going to combine my like terms. So these are like because they both have an x. So 9 minus 6 would be 3x. So I have negative 12 is equal to 3x plus 15. So I want to isolate my variable. I want to get that x all by itself. So next, I need to move the 15 to the other side. So since 15 is being added on the right side, I have to subtract when I move it to the other side of the equation. So anytime you move something to the other side, you do the opposite. So it cancels out on the right. Negative 12 minus 15 would be negative 27. So negative 27 is equal to 3x. Since 3 is being multiplied to x, I'm going to divide both sides by 3 to move it to the other side. So we do the opposite of multiplication, which is division. So it cancels out on the right. I'm just left with x. And then on the left, I have negative 27 divided by 3, which would be negative 9. And that's our answer. Saying negative 9 is equal to x is the same thing as x is equal to negative 9. You could flip it if you wanted to. These are the same. They're both right. All right, let's look at the next one. E. So I'm doing PEMDAS backwards to solve. Remember, I want to get the x all by itself. So I start with anything that is addition or subtraction. So here I have the plus 3. The opposite of plus 3 would be minus 3. So I subtract 3 on both sides to move it to the other side. So that cancels out. So I have 2 times 1 minus x is equal to negative 8 minus 3, which is negative 11. Next, I'm going to move on to multiplication or division. So 2 is being multiplied by 1 minus x. So I'm going to divide both sides by 2 to get it to cancel out on the left. So I have 1 minus x is equal to negative 11 over 2. Next, I have a 1 on the left side. It's a positive 1. So I can subtract 1 to move it to the other side. So 1 minus 1 cancels. I'm left with negative x. On the right side, I have negative 11 over 2 minus 1. So when I have a fraction and a whole number, I need a common denominator in order to subtract them. So this is negative 11 over 2. I want to make 1 have the denominator of 2. So I'm going to change it to 1 over 1 and multiply the top and the bottom by 2. So make it 2 over 2. So now that they have the same denominator, I can subtract the numerators and keep the denominator the same. So this would be negative 13 over 2. So negative 13 over 2. So next, I have negative x. X is not alone yet. I have that negative in front of it. So to get the negative to the other side, I'm going to divide both sides by negative 1. So that turns into a positive. And then the right side's going to turn positive also. So this would be 13 over 2. So dividing something by negative 1 doesn't change the value of it. You don't have to keep change flip. The only thing we do is change the sign. So we're not doing any math there. We just change it from negative 13 over 2 to positive 13 over 2. Let's let's look at F. So here I have to do PEMDAS backwards. Again, I need to isolate my x. I gotta look at x all by itself, so I have to undo everything on the left side. So I'm gonna start with addition or subtraction. So I see that 6 is being added. So to move it to the other side of the equal sign, I have to subtract 6. So I'm going to subtract 6 on both sides. So it'll cancel out on the left. So 3 times x plus 1 is equal to negative 9 minus 6. When you have a negative minus a negative, you add the two numbers together and it stays negative. So it'd be negative 15. Next, I want to move on to see if I have multiplication or division. So 3 is being multiplied to x plus 1. So to move it to the other side, I'm going to divide 3 on both sides. So to cancel, so I have x plus 1 is equal to negative 15 divided by 3 would be negative 5. And you may ask, why do I move the 6 over but not the plus 1 inside here? Because that's inside the parentheses. I can't touch inside the parentheses until I do everything else around it. I have to undo all the things that are touching the parentheses before I can go inside the parentheses. Once I just have the parentheses alone, I don't need them. You can still leave them if you want to keep them in your work. It's no problem. But now I just have x plus 1 is equal to negative 5. So I'm going to move the 1 to the other side. So since it's being added, I want to do the opposite and subtract 1 on both sides. So x is equal to negative 6. And that's our answer. On the next page, we're going to continue to do the same thing, but here we're solving equations with variables on both sides. So to solve an equation with variables on both sides, simplify one or both sides of the equation if necessary, then use inverse operations to collect the variable terms on one side. And then you collect the constant terms on the other side and isolate the variable. So we'll have our variable on one side and then the constants on the other. The constant or the number. So move all of our variables to one side, all the constants to the other side. So let's look at A. So here I'm going to combine my variables together. I have negative 4x and negative 9x. Since I already have a constant on the left side, I'm going to move the variable to the right side. But in order to move something on the other side of the equal sign, I have to do the opposite. So since it's minus 4x, I'm going to add 4x to the other side. So it cancels. So I have 10 is equal to, since negative 9x and 4x are like terms, I just add the coefficients together and keep the x there. So negative 9 plus 4 would be negative 5. And the variable part stays the same, so negative 5x. Again, I want to get the variable all by itself, so since x is being multiplied to negative 5, I'm going to do the opposite and divide both sides by negative 5. So it cancels out on the right, and then 10 divided by negative 5 is negative 2. So negative 2 is equal to x. It doesn't matter which is on which side. You could say x is equal to negative 2 if you wanted to flip it around, but it doesn't matter. All right, let's take a look at B. I'm going to simplify both sides of the equal sign first before I combine any like terms. So I'm going to distribute the 3 to the parentheses, and I'm going to distribute the 1/4 inside the parentheses. So let's start with the left side. I have 3 times 3x, which would be 9x, and 3 times negative 4, which is negative 12. On the right, I have 1/4 times 32x plus 1/4 times 56. So this would be 32 over 4x. So 32 divided by 4 would be 8x. And then same thing here, 56 over 4. 56 divided by 4 would be 14. So now I have 9x minus 12 is equal to 8x plus 14. So I want to get my variables on one side and my constants on the other. So I have 9x and 8x, so I want to get those two together. Negative 12 and 14, I want to get those two on the other side. So it doesn't matter which side you have your variable on and which side you have your constants on. I'm going to move 8x to the left. So I'm going to move that 8x over. Since it's positive, I'm going to subtract 8x from both sides. So it'll cancel out on the right. 9x minus 8x would just be 1x, so just x. So since I moved the 8x to the left, I'm going to move the 12 to the right, that negative 12. So since it's a minus 12, I'm going to do the opposite, so I add 12. So it cancels out on the left side. And I have 14 plus 12, which would be 26. So x is equal to 26. All right, so now let's look at C. So since I have a variable on the left side, I'm just going to move my other variable term to the left side also. So I'm going to get this 3x and move it over to the left. So if I'm moving it to the other side of the equal sign, I have to do the opposite. So if it's a positive 3x here, I'm going to subtract 3x to move it to the other side. So it'll cancel out on the right. On the left, I have negative 2x minus 3x. If they're both negative, we add the numbers together and it stays negative. So negative 5x. And that's equal to 10. Next, since negative 5 is being multiplied to x, I want to do the opposite to move it to the other side. So I'm going to divide both sides by negative 5. So it cancels out on the left. So x is equal to 10 divided by negative 5, which would be negative 2. All right, and lastly, let's look at D. With D, I can distribute the 1/2 inside the parentheses. So 6h divided by 2 minus 4 divided by 2. And that's equal to negative 5h plus 1. So I can simplify this. 6 divided by 2 would be 3, so 3h. And 4 divided by 2 is 2. So 3h minus 2 is equal to negative 5h plus 1. So it doesn't matter if we put the h's on the left side or the right, but we just want to make sure our variables are together on one side and the constants are together on the other side. So to move this negative 5h to the other side, I'm going to add 5h. So do whatever is the opposite. So since it's a minus 5h, I'm going to add 5h. So it'll cancel out. So 3h plus 5h would be 8h. So since I put the variable on the left, I'm going to move my constants to the right. So I want to get this negative 2 to the other side of the equal sign. So when you move it to the other side of the equal sign, you have to do the opposite. So since it's a minus 2, I'm going to add 2 to both sides. So 1 plus 2 would be 3. Now we're not done yet because I need to get that h all by itself. It has to be alone. So right now h is being multiplied by 8. So to do the opposite of multiplication, we would divide. So since we have to move that 8 to the other side of the equal sign, we do the opposite, so we divide by 8. so it'll cancel out on the left. So I have h is equal to 3 over 8. And that's our answer.